Let's get back to the problem of looking for the optimal combination of players for our fantasy football team. And although we can't explore the knapsack problem, the problem of maximizing expected points scored subject to our budget constraints, without some techniques from linear programming or some computer programming skills, we can have a quick look at how we might go about setting up this problem in a way that can be solved by hand for small examples, or perhaps with the help of a computer for large examples. And if you can program a little, you'll find some suggestions for computer solutions online by Googling knapsack problem in fantasy football. So let's suppose we have the following problem. You want to choose 3 players from a set of 3 quarterbacks, 2 running backs, and 3 wide receivers. And you have some constraints. You must choose at least 1 quarterback. You don't wish to choose more than 1 quarterback, so you're choosing exactly 1 quarterback. And you also have a budgetary constraint. You must not spend more than $45. And the value of each player and their cost are shown below in the table below, the value being the points you expect them to score in the upcoming season. We have quarterbacks are named QB1, etc. in the table. So for each player, we're going to create a variable which can take one of the values 0 or 1. And these variables are going to represent the number of each player that we purchase. So we either purchase a player, we don't purchase a player. If we purchase them, the variable takes the value 1. If we don't purchase, that variable takes the value 0. And we're going to call the variables Q1, Q2, Q3 for the quarterbacks, R1, R2 for the running backs, and W1, W2, W3 for the wide receivers. And we're going to use this notation. Let P of Q1 denote the number of points we expect from quarterback 1, C of Q1, the cost of quarterback 1, etc. Okay, our problem with our constraints can be summarized as follows. We'll have to find the values of Q1, Q2, Q3, R1, R2, R3, W1, W2, W3, such that the number of points scored, which is given by the following sum, is maximized subject to our other constraints. And you see that this sum gives you the expected number of points scored for your particular selection. Q1 PQ1 is the number, the amount of Q1 you bought, that's either 0 or 1, times the points scored by Q1. So if you bought Q1, then Q1 is 1, and PQ1 is the points scored, and that's contributed to the points scored, or the expected points scored for the upcoming season. If you didn't buy Q1, Q1 is 0, and Q1 contributes nothing to the points scored or the expected points scored for the upcoming season. So the sum, that sum gives you the total number of points you expect to get in the upcoming season for your particular selection. The following sum shows you the total cost of the players you select, and your constraint is that you want that sum to be less than or equal to 45. So the sum of the quantity of each player times their cost should add to something less than or equal to 45. We have a couple of other constraints. One is the constraint that we need exactly 1 quarterback. So that amounts to saying in mathematical language that Q1 plus Q2 plus Q3 must add to 1, since exactly one of those must be 1. And then we must choose exactly 3 players, so the total sum must be 3. So a solution to the above problem is going to be a sequence of 0s and 1s of length 8, and it should satisfy all of the constraints. So there are 256 possible sequences of 0s and 1s of length 8. You can figure that out. That's 2 to the 8. It's just like heads and tails. but not all of those 256 sequences are going to satisfy our constraints. So the constraint that 1 equals Q1 plus Q2 plus Q3 means that there's exactly one of those first three variables which can equal 1. So for example, Q1 equals 0, Q2 equals 0, Q3 equals 0 is not allowed. And putting that together with the second constraint that we have exactly 3 players chosen, we get that exactly 2 of the remaining 5 variables must equal 1. So there are exactly 10 such combinations of these latter 5 variables, the R's and the W's, and we can put any of these 10 combinations together with the 3 possible choices of quarterback to make 30 possible combinations of zeros and ones of length 8, which fit our constraints. And on the next page, we list all of these 30 combinations, and we calculate the cost for each of these to check if it's a feasible combination, if it's less than or equal to 45, and then we choose the one which maximizes the points. Here we see a list of all possible combinations, and you see for this first combination we choose quarterback 1, running back 1, and running back 2. So we don't choose any wide receivers there. But the cost of that particular combination is 56, and that is too much. It's more than our budget will allow, so it doesn't satisfy the budgetary constraint. So we don't even bother calculating the points there because that's not a feasible combination of players. And for the feasible combinations of players, we calculate the points we expect them to earn, and then we actually choose the actual combination with the maximum number of points. So here's a feasible combination, Q1 R1 and Q1 R1 and W3, and it costs exactly $45, so we can buy that particular combination, and the number of points are 670, so that is a feasible combination, but it's not the one that gives us the maximum number of points. That's given by R1, R2, and W3. So that's the combination which gives us the maximum number of points given our constraint, and that's what we should go for.